Okay, so using the simple pendulum to measure acceleration of gravity g. So in our tables we have our formula, which we have to accept. T is 2 pi square root of L over g. So T is the periodic time, the time for one oscillation. L is the length of the pendulum, and g is the acceleration due to gravity. Now the length from the centre of the bob to the bottom of the split cork, as we'll see. Square both sides, rearrange, and we get y is equal to mx, t squared on the y-axis, L on the x-axis, and we get a slope of 4 pi squared over g, so g is 4 pi squared over slope. It's rather interesting that pi squared is very close to g, as it turns out, if you look at them. Okay, so the slope is approximately 4. Okay, so if we come back to our apparatus, very simple apparatus. Okay, so what do we have? We have a split cork here. Okay, so cork split in two, and that allows us that the pin or that the string always swings around one point. That's the whole idea of the split cork. And we also measure from the bottom of the cork, and we measure to the centre of the bob. Bottom of the cork to centre of bob. Okay. Now, the formula only works if the pendulum obeys simple harmonic motion, and that's why it's then called a simple pendulum, and that only applies when the angle is small. Okay, so you set it swinging like that through a small angle, and you wait until you're ready, and then you start measuring your time. I'm going to start measuring the time from when it gets to the left the next time. So I say start, 1, 2, 3, and so on. Now we measure the time for, let's say, 20 oscillations for a certain length. Divide by 20 to get the time for one oscillation. Why bother? Why not just do it for one oscillation? We all know that. The time for 20 oscillations will be a larger number. The time for one oscillation will be a smaller number. The larger your measurements, the smaller the percentage error. Remember, percentage error. So you can measure the time for 20, let's say, therefore the periodic time t, the length L for that length, and we vary the length. Do it 5 or 6 times, draw a graph, get our slope, and therefore get g, and of course we expect our value to be about 9.8 meters per second squared. And this one works really well, really well.